Hi, good afternoon, everybody. This is Joe Wilkie from SolidWorks Corporation. I'm joined by Rob Stoklosa from TPM, and we're here to talk to you about SolidWorks Electrical a little bit. So thanks for taking the time and joining us for this webinar. I'm just going to spend a few minutes giving you guys a little background on SolidWorks Electrical. From what I understand, most of the attendees are pretty new to this, and so I'm going to walk you through some of the basics of kind of how the software works and what it does for people. And then we're going to hand it over to Rob for the bulk of the time to take care of a demo. But we'll just spend a couple minutes here up front setting the stage for Rob a little bit. So SolidWorks Electrical brings together the benefits of parametric design to the electrical engineer. It's built entirely for the purpose of creating schematic and supporting documentation, and it gives the team the tools that they need to create virtually any type of schematic quickly and efficiently. It includes libraries for components, cables, wires, symbols, really, and you can customize that to meet your own needs very easily. It also provides tools for doing layouts, either in 2 dimensions as 2D CAD drawings, as most people do it today, or inside SolidWorks 3D CAD for better coordination of resources and placement of components and routing options with the mechanical team. And finally, it includes tools to automatically produce bills of material, wire from to list, labels, really whatever types of reports you might need. And in addition to the standard production style reports, SolidWorks Electrical also includes design rule checks to help you catch common mistakes like short circuits, excessive power loss or voltage drop in cables, or even an invalid wire size going into a given terminal. So just about 8 years after it's released, SolidWorks Electrical has delivered tremendous value to thousands upon thousands of customers. And the kind of feedback they're typically sharing with us is that they've been able to reduce the time to produce all the documentation we just described by about half or more. Another great benefit is that they spend almost no time checking their work, reviewing their reports for accuracy. They just know that the data is rock solid, and if they've designed the system correctly, they know all that data is going to be correct. And that's great news for them, really, because checking all those reports and verifying all that data for errors was really the least exciting part of the job. Designers would like to design in general. And finally, SolidWorks Electrical is built to support a collaborative design process. So that means multiple electrical engineers can work together, and even mechanical engineers. They can all work together on the same project and make one set of documents for everybody. And the main benefits of this was, well, you have one set of documents produced by many people, and it's always accurate and up to date. And so the accuracy is a huge benefit, the time savings, and also just a huge increase in productivity from the reduced need for team meetings to sit around and figure out where the design's going next. Everybody's always on the same page and up to date with SolidWorks Electrical. So at the risk of grossly oversimplifying what you guys do, I'd like to break down the most common process that we see among our customers for developing electrical schematic documentation, and I'll break it down into just 3 steps. So the first step is usually just to draw the system in CAD to visualize how it's going to work. So we might create all of our symbols, create all the lines and wires to connect those symbols together, and we may even start figuring out what parts specifically we're going to use for that task. The next challenge is to fully document all of those project details. Most often this is done in spreadsheets or other reports that are going to different audiences. For example, my purchasing agent wants a bill of materials, so that they know what supplies to order. My shop technician would prefer a wire from to list rather than walking through dozens of pages of schematics trying to see where each wire ends up. And since these spreadsheets that I'm creating for all these different audiences in my schematic are really very different documents and not really linked together anywhere but in my mind, I'm going to spend a lot of time checking my work. Long system audits to make sure that every cell and every Excel sheet is the right value. These are not things we can spell check, so this is a tedious process. And the challenge that most people realize is that as their project grows in complexity, the amount of data they have to manage just seems to grow exponentially. It just grows into levels that are virtually unmanageable. And let's take a look at a simple example. We'll just walk through the process of documenting a power supply. So this is something I see often. People tell me they can create that symbol in their CAD just as fast as they can create it in SolidWorks Electrical, and they're probably right. It doesn't take but a few seconds to put that onto the drawing. But the challenge is at this stage, I don't have any idea what part that is. I don't know the voltage in or out. I just know we have an AC signal on one side and DC on the other. That's all I know. So what we need to do is get out our text box tool and add about 10 attributes around this to fully define it. Tell me who the manufacturer is, what the part number is, what the voltage in and out are, all those kinds of steps that are things that I need to keep up with. And then that's only getting me done with the drawing process. That documentation process where we have to put this on spreadsheets is another step. So now we're going to take those values that we put in the attributes and we're going to spread them out across and duplicate them as needed across 12 more rows in 3 separate spreadsheets. I've got a wire report, I've got my wire labels or my device tags, and I've got my my bill of materials. So I add those 3 spreadsheet documents on top of the CAD document. I've got 4 documents I'm working with right now to track these 10 values. And in this example, what I've done is I've put everything from the system from multiple pages all on one screen for you, and heck, we'll even color code the variables here so you can see what we're working with. That's a lot of data from one simple device. It's just a 24-volt power supply. But I've got 41 values in 12 rows in spreadsheets on a CAD drawing and representing many different uses of the same variable. And so for people who seem to like that approach of using general purpose CAD for doing their drawing, and they use Excel because it's very easy and anyone can kind of open up Excel and more or less know it, the real challenge comes in those audits, because if you make a typo, it's hard to find. I don't know if any of you have already spotted already. I mean, it's color coded and on the screen, so hopefully it was easy to find. But my experience is most people don't find it within 30 or 45 seconds. And there it is right there. The very first item I personally typed in manually into a spreadsheet, and I got it wrong. So I have a 100% error rate coming out of the gate there, and that's not a good thing. It took me a while to spot that. So SOLIDWORKS Electrical does a great job handling your data for all the components in your electrical project. It keeps up with the wire numbers and labels and makes all those reports and all that work. And then as we back out to more of a project level management tool, we also support PDM Professional. And so whether you're using electrical 3D to do your panel layouts in a mechanical 3D layout, or if you're doing simple 2D panel layouts, you can use SOLIDWORKS PDM Professional to manage all of your organization's data. And with your electrical and mechanical data under one management system, that means your team will be able to work more efficiently. They'll have integration that enables them to take advantage of the bill of materials management tools and consolidate an electrical and mechanical BOM to remove any duplicates and make sure that nothing's double ordered or avoided, accidentally not ordered. And what it also does is bring the electrical engineering team into the whole, all the workflows that you can define in PDM. So whether it's an approval process or a request for a change or something along those lines, these are all things that we can do inside SOLIDWORKS Electrical. And of course, if you're working in multiple sites, this is really a must-have, because PDM is going to take care of replicating that data wherever it's needed, so all the different stakeholders on your team can get access to it. So there's a lot of power and a lot of value that comes in with the PDM Professional. And with just that quick summary of what SOLIDWORKS Electrical is, it's a tool to help you make schematics faster and create all the related documentation really easily. I'd like to hand it over to Rob, and he will show you a demonstration.
Thank you, Joe. We'll hear from Joe in a little bit. Maybe he can give us a recap on the webinar's events here, and we'll open it up for question and answers towards the end as well. But well done. Okay, he's going to hand that over to me.
Rob is the presenter.
Rob is the presenter. Show my screen. All right. Well, thank you for everybody for taking some time here and generate some interest in this product. I'm going to take you through just kind of a standard workflow, kind of the day in the life of an electrical design. The first set of tools here that we're going to start to look at is just getting some concepts down on the piece of paper, if you will, right? Drawing lines, it's something we do every day, but as you can see here, it's a really quick and orderly operation to get that kind of concept on the screen, right? So here I'm just illustrating a couple of the tools that we have to get a three-phase circuit laid out, if you will. I'm also going to take you through the line command or the wire command, if you will. It's kind of intuitive. I can generate a wire, and even if I were to put a wire on a wire, you'll see that SOLIDWORKS kind of understands that, right? So it's checking to make sure we don't do anything crazy. At the same time, when I generate a wire that has a connection point between an existing wire, you'll see it generates that connection point automatically and separates that existing wire from continuity. So getting this on the screen, for those of you that have done this in the past, it's real simple. I'm going to start to add in some symbols to this circuit at this point. And we have a couple ways to do it. I can go to my library here on the right. However, in this case, I do need to look at my library a little bit more intuitively, if you will. This is the library of components that comes with the program, and you can see on the left there's a lot of inputs that you have as a designer. So it really helps you streamline down that component and getting out of that what you need. We're going to place these fuses in place, and you can see it just kind of snaps in through kind of a grid-like feel, if you will. And then I'll go use this symbol library on the right. And this is great when you already know kind of what you need. You're not really paring down anything. I'm just able to go in there, put in a circuit breaker, put in relays, and literally drag and drop these symbols out onto my circuit. All right, so we'll look for our contact relay, 3-pole, and again, as long as you know what you're dealing with, this becomes a pretty fluid system. And this library can be pared down, so if you don't use all these symbols, don't fret. That's something that we can help get a little more logical order to, if you will. All these libraries that you're going to see today are managed on the backbone of a SQL database, so it makes it real easy to adjust those and have that change propagate through your company. The last thing I want to add here for the symbol wise is just going to be a terminal across there. That motor will be in a different location, but let's go ahead and add in our terminal block. And for this one, I am going to utilize this filtering, if you will, just so again to help me pare down what I need. And for this case, I'm going to go ahead and identify the amount of circuits that I currently have. A lot of times we go into our library, we don't have what we need, right? Or we have to adjust certain components that are currently in there, especially when you're coming up to speed and building that library. This particular part only had 3 circuits assigned to it, so I'm going to make a change on the fly for this particular project and just simply add in that ground terminal that was required for the 3-phase motor. So we're just going to adjust the symbol, add in the ground, accept everything, and you'll see it got pulled away, but that's simply because I'm still looking at the 3-circuit filter, right? So as I change to 4, we can see my component now is there. So I can go ahead and select that, and it now knows the component that I'm going to use for this terminal block, and I'm just going to accept the terminals as they are. What this gives me in this case is a multi-level terminal, as you can see. The nomenclature you see today, please take that with a grain of salt. We can always address that. The second step, if you will, after I've laid out that circuit with the symbols, is to assign the manufacturing part. So when I buy that symbol, right, what am I actually purchasing? So now I'm assigning that kind of information to the symbol, as Joe mentioned. All right, you remember his little slide he had with all those lines going back and forth. That's what we're doing right now. We're capturing that so we don't have to manage that. As an intuitive kind of option that SOLIDWORKS Electrical brings to the table, you'll see those red symbols in the bottom right. They're now green. As I go through and I scroll through my different components, I also have this kind of checks and balances as a designer to make sure that I'm not putting a component in there that can't really operate in those conditions, right? So there is a feedback mechanism there to make sure that we're attaching the right information. Just as a variant, I'm going to go ahead and just change this up to look for a description. I've been looking for circuits. So let's go back to all circuits, because let's say I don't care about the circuits, but I know the description. And once again, you'll see it pairs down looking for that word in the description. It is an extensive library, so you can manually go through this thing. However, I would encourage you that part of our implementation is to pare it down first, get these filters in place, and I think you'll find it a real easy environment to mitigate and find the data you're looking for quickly. So in short order, we were able to get that, that motor circuit in place. The next thing that I'm going to want to take a look at here, excuse me, this up, is I want to just make sure that it meets my company's requirements. So we have something called a design rules check, in which I'm going to add in the check that I want. So you have quite a list here, right, that you can choose from. Today I'm going to look for components that I don't have a manufacturing part attached to. So before I send this through my process, I want to make sure I don't just have dome symbols sitting in there, right? I want symbols that mean something. In this case, it indicates that M1 motor is still kind of sitting out there, right? It doesn't know what it is. So I was able to identify that, and now I go through that same process again, going through my library of components and identifying the manufacturing part for that motor symbol. If we run that rule check again, you'll see that symbol is now no longer listed in that list. So I've taken care of my job and kind of check, right? I'm ready to go on to my next step. My next step for this was to actually put in several more circuits. We have a couple of lines that require this same kind of circuit for the motor. So I'm just going to go ahead and do a copy and paste, right? So a lot of times we have circuits that we know work. We've proven them out. There's no reason to go back and rehash all that. Let's take a look at the terminal strip that's being generated in the work I've done. So you can see I haven't done anything, but this is what's been generated. I have a really clean outlook of how the cables go into the wires go into the terminal block and how they go out. However, I don't want wires going to that motor. I want to make that a cable. So I'm going to go ahead, quickly undo what I did. Let's go fix that and not propagate that change forward, right? So we're going to go back to that first circuit, and I'm just going to identify that those 4 wires going to my motor from the terminal block are actually a cable, all right? So they have cores in it, or it's a cable with cores. So now I'm going to look for that cable out of my manufacturing parts. And again, you see cables, we can identify them and search for them in a whole different manner, right? I have one I generated that has 4 conductors already placed here, so I'll go ahead and select that. And now I just need to kind of tie the cores of that cable together with the wires. So a quick highlight here, and I'll associate the 4 wires that I have to the new cable cores that I've generated. And now I have a W1 cable in my project, and that's listed. So real easy to kind of work with that terminal block environment. It's one of the main benefits of the program. At this point, now I've got a cable. It's called out. Let's go ahead and copy and paste that and propagate that change forward, noting that the cable is now W2 on that copied circuit. If we edit that terminal block, we'll see that the same changes propagate. So very little work, right? Once we get the first circuit right, we're in pretty good shape. Now that we know that thing works well, let's go ahead and kind of publish it, if you will, to our company, because we want everyone else to be able to access that same circuit. So we'll just go ahead and highlight the circuit that we want to pull into our macro library, drag and drop it, and provide a quick name for what that circuit provides us.
So anytime anyone in my company needs to start that particular motor, they could just search for the name of the macro, and they know the right circuit breaker to use, the right contactor, the terminals they want, even down to the cable of what you need, the whole system. If I know one part number, I have all that data. Is that?
As long as they can halfway spell, Joe, the answer is yes, right?
Good point. Got to put it in the database in a way you can find it.
Yeah. So I'm going to go ahead and reuse that data. I'm just dragging and dropping it into the open space and placing it. You'll see everything gets indexed up real nice. It's really not a worry, all of our relays. Now this is a really neat thing. Since I have a multi-level terminal block, I wanted to show that ground wires coming into 3 places. So let's go ahead and bridge them together. So we only got to run 1 wire, and then we'll kind of jump over to those others. So a real quick way to do that. Once I've got a terminal block that looks okay, I'm going to go ahead and publish that to my project, all right? And what this does is it kind of exports this data into a manner that maybe other people in the company could visibly see. In this case, it's a drawing within my project for electrical, but you'll see it's more that traditional terminal block drawing, although very beautiful, right?
One of my customers referred to that, Rob, as a field wiring diagram, because all they care about are the cables coming out of the box when they get it to a job site. So that's another
Right, that feel, so that is an important part, and I know that it impacts you guys greatly, so I just wanted to make sure we illustrated that. I'm going to continue working on that circuit, just creating a new page. I have some more work to do, right, as we usually do, so I just create a new page, and we'll get that same wire scheme out on there and drag that same macro back onto my page, connect it in, accept my indexing, and now have my other motor in. I'm going to go ahead and rearrange that tree because, as in real life, things don't happen in a logical order. We have to make audible things happen every day. So just know you can this works with you. It's very fluent and flexible. I'm going to go ahead and renumber those documents once I've made that change, so it's a little bit more logical for whoever gets this project next. And now we have that, continuation from the 4th sheet to the 5th sheet of the circuit. Now, although it's logical in my tree, it's not necessarily logical in the program. So one last step to that is simply to tell the project where the circuit continuation is, if you will. So for that, we're going to use a multiple insertion from to arrow, where I just simply go through, select my lines or line, and then it will find that corresponding connection. As long as there's continuity between those, wire types, it will find that, and it creates that hyperlink. All this data that I'm doing, or that you're seeing here, the hyperlinks included, are going to be included in our exported PDF that we'll see in a moment. Pretty cool, right? So I know for me as a mechanical engineer, which is what I am, that was very helpful to just simply go to. My last step to this really is to update that drawing. So we're going to go ahead, right click, tell it that I made some additional changes that I want included in that terminal block drawing. And we'll go ahead, and you can see now it's just created another sheet because I ran out of room. And it's also indicated through the red there that I kind of need to go jumper that ground wire, right? So there's some checks and balances again, but as you can see, as I do my work, this program's keeping up with me and doing the things that traditionally you had to do manually. As a nice bonus that we like to add in that doesn't take much additional work, we like to add in what's called a line diagram. And again, this is not something traditionally we see, but we encourage you to look at. The first thing I'm going to do here is actually create a new location and start to organize my project a little bit further now and get a little bit more into the weeds with how this is categorized. So I created a new location that refers to my shrink wrap line, and I'm going to drag and drop any components that are in that location. So we have the main electrical closet, right, which is where we'll house most of our components, but then as those motors and infrared eyes and things like that, they're going to be around the plant. So we can create locations and place them there. The next step is simply to start, right click, insert, and place the symbol that we want to reference that component in our line diagram. All of our symbols is because if look at Joe's slide or recall Joe's slide, everything is related. So all I'm doing is right clicking and saying insert, and it knows, for instance, the symbol to use for that particular terminal block that we had. So this is a really fluent system. As long as everything is communicating correctly, you can see that you're not doing the work twice, right? That schematic is where we did a large part of our work. Here we're just kind of placing it and putting it on the screen. I'm going to go ahead and connect these symbols with some red lines. Oops, skip that one. Moving a little fast. And these red lines aren't lines, they're actually cables. So we're going to go ahead and, you remember when I converted that cable over earlier, this is just another method that you have to do that function with. I can cable things from wherever I want, wherever is appropriate. Once I've drawn that red line representing a cable, I've got a lot of stuff I've done, so we're going to go ahead and just tell the program to kind of recalculate things, make sure our wire numbers are up to speed, and then I'll tell it to renumber all my marks, and that's what will indefinitely give me the indications for those cables. So very quick, couple clicks, and you got quite a project going here. Before we get out of that project and continue on, I want to just kind of show you some of the options you have in way of reporting. Simply coming in here, selecting the reports that you want, gives us, you can see a preview to the right here, This is going to be bill of materials, our from to lists, right? This is where we generate that kind of data. And you can see that this, what you see here, has been generated as I've been working today. So I've done nothing other than place these symbols, where they belong and attach the components. Now that things look good, let's go ahead and create a 2D cabinet layout. So we're going to go ahead, select our main electrical closet, and I'll go over here to our 2D cabinet layout. And you can see the toolbars across the top change, as they most often do in any SOLIDWORKS product, to try to follow where we're at. So for this one, we're now in a cabinet layout, toolbar. It's a little different tool set, but you'll see that identifying and inserting this data is the same as you saw before. A right click and an insert, and because of the structure of this program, it knows the symbol to use for that particular component. So I'm just kind of eyeballing these onto my sheet, locating them about where they would need to be. We can make some fine-tune adjustments, as we increase the detail that we get on here and try to find that room that we're always looking for. Put my terminal blocks in, and again, I'm just laying this out. At the end, or however you work, you could do this in the beginning, but we're just going to go through. I'm going to add a duct just to show you how this works. Now, ducting, you do have a component, so your sizing and everything is all up to you. But you just kind of drag these things across your component, and then we tell it that it's in the background or the foreground. And you'll see the same response when I do the rail here. Anything that you're adding to this 2D drawing, it's really fluid, it's really smooth, and I find it really easy to work with. You just kind of got to get the stuff on the screen, and then you can manipulate it to get the representation graphically that you're looking for. The last step I might want to do here is just simply enclose that in something we might cut out at the laser, some kind of plate, put a couple holes in it, dimension it, right? But we have a pretty quick layout that's now included in this project. At this point, I could go ahead and say, let's move this on, right? We'll export this out to a PDF file. You have quite a few options for how you want to handle this, but more or less, we would post this to a PDM system or whatever you're running, and that PDF becomes our document that we're sending through the process. On the other side of the fence is our mechanical team. So now that PDF is kind of sitting there waiting for approval, the mechanical team, they're not sitting idle waiting on it. They're doing other work, right? We're doing work in this case that was for a power supply that has already been approved. So here I am, I fire up my SOLIDWORKS program, I check out my data like I normally would, and the only difference is I have this extra button on in my interface here, right? So the same thing applies. I find the parts that I need to work on, I right click, I hit insert. We have some whiz-bang mating techniques that are built into these components so that it finds the DIN rail real quick and just kind of snaps to it. So you don't have to be a SOLIDWORKS expert. And then at this point, now that I confirmed my components in place, I would just simply tell the program to route wires. And I have the choice of, how extensive this is. It could be 1 or 2 components, or I could go for the whole system as a whole. In this case, I chose that one power supply, and you'll see the red wires are what I actually am telling it to recalculate, so you'll see those appear. But it goes through, it's looking for the pinout connections. This is all based on that schematic information and those components we just looked at. So there's no wizardry here. It's just we're looking at a schematic that has that detailed information. And there's the red wires in place.
Right. And so now you have a 3D cabinet assembly, and the system knew which parts to put in and how to follow the wiring paths automatically?
Automatic, right? Like I say, Joe, it's all automatic. Yes. As long as your schematic is right, it is automatic.
Your schematic is right and your library is properly set up, exactly?
Correct.
Yeah. So the wires know to look for ducts, and they know where to land on each component.
That is the truth too. You'll notice those wires were run through the ducts. They knew the cable trays, right? And there is some rules we can apply there. So if you're looking for high voltage and low voltage segregation, we can talk to you about that. Yeah. We can go ahead, save this, and check this back in since I've done my mechanical work. The mechanical work's a lot easier, isn't it? You guys are gluttons. All right, I'm going to hop over to the back side of this whole thing and just show you PDM and how it's been running all this. I have my SOLIDWORKS library in here, so that's managed. I have my projects with, you know, standard PDM templates. That's all managed. And then usually what we see is we just create a separate folder that kind of houses some of that electrical information. So your mechanical stuff, you know, we don't touch it. We just kind of add to your environment. And then for those of you that really aren't familiar with PDM, I'll just give you a quick run through. You know, this is a Windows interface, so you just kind of right click on your stuff, you check it in, you check it out, you send it through state changes for approval. It all can be done through your interface. And then we have comments associated with every move that we make. You saw me put a few comments on through the demonstration. Those are great because they're attached to, you know, this place and time. It tells the rest of the company why I did what I did and who told me to do it, if you will. Responsibility. So we've gone ahead and just sent that 3D data through the process. And then I'll just send it one more time just to show you how it, right, just follows through. Okay, so the 3D data now that we looked at, that assembly, that's sent forward, right? And they're looking to check that. My project I did today, however, that PDF file we generated, that's also in here, but it's pending approval, right? Because those are some additional changes. We added motors and things. So you can see these don't have to be a parallel process. They can disjoin as long as they come out in the wash. And this is that great documentation we've been telling you about, that with a few clicks you generate all these from to lists, all these bill of materials. It's got the schematics, the detailed schematics in it, and that nice line diagram, you know, for those higher level 20,000 foot overviews of your system.
You said the hyperlinks all carry through in that document as well? So if you click on a circuit breaker, it takes you somewhere else?
Yes, they do.
Very
and that's
cool.
a great benefit as well, because a lot of our companies are utilizing this type of data on touchscreen monitors and things in their shop. So it gives them a whole new way to interrogate that data.
All right. Yeah.
All right. I guess. You want to wrap that up, Joe, or just kind of?
Yeah, absolutely. What I can do is I'm going to find my little console here to switch back to the presenter. And we got to look at the audience view. Yes, okay. So that was the demonstration. So thank you, Rob, for taking us through that that demo. Gave us, I think, a very good. When I was just kind of making some notes as I was watching, and you know, when we talked about that kind of simplified view of SolidWorks Electrical, that draw, document, audit. I think when we saw everything that Rob did was really kind of designed with the schematic designer in mind. When he had to draw wires, he didn't pick a, you know, create a new layer so it would make a new color line for him. He grabbed a wire style for multi-phase power, and he was able to draw, and he was able to bend and fold and invert those lines very easily. What I also noticed is when he had to put a symbol on the lines trim themselves automatically. So when we have customers that are using tools like DraftSight or AutoCAD or similar tools to that, that's one of the things they notice right out of the box is just how efficient it is to get your idea on the screen without all those details, you know, without all the trimming and extending and operations. You just drag the symbol on the wire, it breaks the wire, creates the two connections. Those connections go into a database, and now you have a from to list. And you delete the symbol, and the wire heals itself again. So it's really very powerful, you know, functionality there. The automatic terminal strip drawing for the terminal wiring, as well as field, you know, cabling kind of application, is very powerful. So there's a lot of the drawing side that was happening with a lot of automation and optimized tools. And then when you got into creating the terminal strip drawings or all the reports, those were all fully automated. So that was also very powerful. So if we look at really what SolidWorks Electrical does, I think from the drawing stage, it just makes these tasks a lot easier and faster because it has tools that are designed with the schematic designer in mind. And if we look at the other tasks there, the tasks of, you know, looking, you know, filling in all the attributes into a table and for a spreadsheet, for a report or something like that, you realize that those are the things that we really do fully automatically. So we really save a lot of time there. And that's by the way, where most people tell us they're saving, 40, 50% of their time. And then the schematic savings is another incremental savings on top of that. So that's why most people are telling us they're saving more than half their time for all related documentation tasks. And they're able to get it done faster with higher accuracy and, much better result. We had a customer, a case study we put up on our website just recently for a company called Select Technologies. And what Select realized is after 4 years of using SolidWorks Electrical, or I'm sorry, 5 years after starting to use SolidWorks Electrical, their estimated savings on projects in terms of labor is about 10,000 hours. So their 4-man electrical engineering team is effectively getting an extra 2,000 man hours worth of work out of them, which is the equivalent of adding a full-time hire. What this has allowed them to do is just streamline their process, get their work out faster, take on more work without having to add headcount, which is very expensive, for these companies. So, and the great thing is their engineers are fully utilized doing actual engineering and not so much times, auditing spreadsheets. So if we're going to wrap up the real summary here, what did we find? We saw that we could create parametric schematics very effectively, like Rob did with that motor circuit. We can reuse that data. We can create automated drawings like the terminal strip drawing that you saw. We also do the same thing for PLCs. We can do, excuse me, I'm messing up with my arrow keys. We can also do panel layouts in 2D or 3D. It doesn't really matter. You can do either. Some customers see a tremendous value in going to 3D, and some are very happy to stay with 2D, and that's perfectly fine. And then we also generate all those reports and data design rule checks as well to really help you stay on the same page and stay free of errors. But really one of the largest benefits come with how the SolidWorks Electrical user can interact with their team. Because the software is built right out of the box to be collaborative, you can just connect 2 users on SolidWorks Electrical Schematics Professional, and they can be working together and sharing libraries and working on the same project simultaneously. You add in a mechanical engineer with SolidWorks CAD and our electrical 3D add-in, and now you have the physical representation of your design able to be to realize that in 3D CAD, and that's also a very powerful feature there. And then, of course, it'd be remiss if we did not mention the power of the community of SolidWorks users. We're talking about millions of people worldwide, hundreds of thousands of companies that are using SolidWorks products and other Dassault Systems products as well. And that's running a range of disciplines from electrical CAD to mechanical to manufacturing software to management of project data, to creating really great technical publications. So there's really just a great deal of great number of resources out there that you can work with SolidWorks Electrical. And if there are questions from the audience, we can maybe field a couple, but in the meantime, I'd like to thank you guys for your attention. And please get in touch with TPM, with your sales associate, or with Robert, or even myself, if you like, and we'll be happy to help you out with this selection process.
I'm not seeing any questions, Joe.
Okay, then I think we're
done that good of a job. So, like Joe said, feel free to reach out, everybody. Don't go at this by yourself. This is what we do week to week. We deal with multiple different companies in different industries, so we have a really good idea of how to approach this. And that's really where TPM and guys like myself come in real handy. We just we take that implementation time down to a pretty short period. So. Right. Please feel free to reach out to us. Joe, thank you very much for your time. And everybody have a great afternoon while there's no ice in the Carolinas.
Enjoy your ice-free day. All right, thanks.
Ice-free day. All right, everybody. Thank you.